Hello and welcome back to a new C++ tutorial video on the Ludwig Fusel channel. So in the last video, or better to say last two videos, we talked about if, else if, else, for, and while to basically make our code more dynamic. So we basically read integers and we checked for multiple conditions that can happen while reading the integers. For example, the correct condition that everything was right, the end of file conditions if we had an error there, the condition that the count needs to be bigger than 0, or that the input in general needs to be numbers. So we basically use if and else to basically check what happened during code execution. This is especially important when you have user input or anything that can change, like reading files, which we're going to do in the future, having user input, communicating over the network, everything you want to do. At some point, you're going to be at a branch where you need to decide what you're going to do. If you just do some static stuff, you don't need to really write the application. But yeah, it's basically a nice thing to basically do it and have it in here, and it is like used all the time, like if and else, like most thing you're probably going to use in programming in terms of structure from the language. For loops, on the other hand, were very helpful in doing ranged loops. So we basically started at a certain value, in this case, for example, the integer value I, starting at 1 and going until count. So small or equal, as long as it is small and equal, which means everything from 1 up to the value count itself, we basically go through it. Already told you that you can use the for loops for other things as well, but we're going to see these other things in the future. So that was all nice and easy to use, and we saw the advantages here. And today we're going to introduce a new concept of the language called arrays. And arrays are very tightly coupled with pointers, so you probably should have watched this video too. I in general recommend watching like the videos in a chronological order, but if you haven't watched the pointers video and the memory video, I highly recommend doing this first, because arrays in C and C++ really don't exist. Arrays are pointers and some metadata that is attached with them, but this metadata needs to be managed by yourself as a programmer. So what are arrays? So in general, if you take a look at this, we have used variables very extensively. For example, we have used the 32-bit integer variable x and count here to basically read our x value and our count value to then execute our print. We have used this int value r0 and r1 to basically get the result of our scanf function. So reading the input from the user and the result of that read execution was stored in R0 and R1, which we could use to determine if we had an error, if everything was correct, or what specific error we had. So we use it quite a lot. So these are basically the idea of a variable. You have a temporary value that you have on the stack. We talked about the stack in a memory video. Some temporary value on the stack that you use to store some data, and then later on use it, for example, to decide what you want to do, or pass it as an argument to a function so that that function can operate as you desire or the user desires. And that's really nice, and that's exactly for what variables are there. But there are also sometimes different use cases of a variable. For example, if we go down and take a look at our execute print function. As you can see, our execute print function basically has not being conformed with the IPO principle that I introduced. Normally you want to do first your input, then the full processing, and then the output. That's like the normal thing you do. IPO, import, processing, output. But as you can see, we are not following this here. You can see that the for loop basically computes the y value and directly outputs that. If you would want to follow the IPO principle, you would need to do something like that. You would need to create a second loop that loops like that. And inside of the second loop, I can actually get rid of the brackets here. If you just have one statement under a for, a while, or an if statement, you can get away with not writing the brackets. However, I do not consider this to be a valid and good programming style, since the brackets are very useful if you want to add anything later on. And as you can see now, we are getting an issue. Like now we are fully conformed with IPO, at least from the flow of our application. Of course, it would be more better if we would have a compute function and the print function itself, so that we would have something like execute or compute and execute, or compute and print, so that everything is completely like decoupled. But in our case, if we are taking a look at the flow, we are inputting we are outputting or we are inputting, going into a function, computing and outputting. So this would be totally fine with the IPO principle. But as you can see, the y value actually, the y value is not known here. So you can see that the identifier y is unknown. This is because y was computed in that for loop. Now you would be tempted to say, all right, I'm just gonna put the y value up here and do it like that. And this would be also totally fine. But if I would run this now, is it set it? Yeah, it's set as the run startup application. So if I would now enter like 10 and 5, you can see that the result values are always the same. It's always 2755. This is because that the last iteration of our for loop here is overriding that y value. So you can kind of like see that every time I compute a new y value, the old one is overwritten. And that's not really something that we want to do. So that's not really fitting for our case. So we would really want to change that. How can we change that? Well, we could change this by adding more y values. y0, y1, y2, and y3, all right? Yeah, would work. So in the first iteration, we would set y0. In the second iteration, we would set y1. In the third iteration, y2, and in the fourth, y3. Now we would just need to do something to decide when we want to do it. So like if we want if I is equals 1, we want to set the first one. If I equals 2, we want to set the second one. I don't know why it doesn't like my coding styles here. I like them. Or maybe, yeah, I think it already automatically done this like that, so I'm okay with that. Even though I like my styles as well. So you could do something like that. But as you can see, that's not really good. You can see that we have a hell of a lot of code duplication. It's not dynamic. We always need to add new values. I mean, like this works, yeah? This works totally fine. And this will work for... okay, this doesn't work because now we need to do the same thing down here as well on the printing. So if I equals 1, then we want to print that. And 1, 2, and 3. And then we would need to do 2, 3, and 4 here as well. And if I would run this now, it's gonna work, and I can enter like 5 and 1, and it's gonna work. If I run this again and enter 5 and 3, it's gonna work. 55, 155, 305. And if I would run this now with 5 and 4, it's still gonna hold up. And if I rerun this with 20, not gonna hold up. You can see we are kind of like limited to the code duplication that we have. And every time we introduce a higher number, we're gonna have an issue. So we will potentially need to cover all cases here. And that's going to result in the 100-line function, 1,000 lines function. And it can't be really that you need to do this like that, right? It's not really meant to be like that. Or is it? No, it's not. It's obviously not meant to be like that. It's ugly as fuck. We don't want to do this. So what we basically want to do is we want to have a variable, for example, called y values. And this variable should now hold, this one should be in32t times count. So as many 32-bit integers as we have a count above here. So we basically want to create a range of values. And how can we do this in C? We can do it with arrays. So an array is nothing more than a list of values. So basically, the difference between an array and something like y0, y1, y2, in terms of memory layout, it's not a difference. At the memory, no, I don't want to edit my power plans. I want to add the editor here, Notepad. So in terms of memory layout, if we would take a look at the stack, or let's maybe say do a code section first. So in32t, let's just call it array, and do in32t 3 times or y0, y1, and y3. So if we would take a look at the stack at these both variables, it would look very similar. Let's just assume that the stack starts at 1, and let's just maybe for simplicity make these 8-bit values so that I don't need to overthink stuff. So that the array would basically then be the value, the first array value, or let's also keep this the programmer style and make this a bit different. So array the value 0, the value 1, and the value 2 would be inside the array. On the other hand, if we would have this something like that, then basically on our stack we would have y0, y1, and y2. So you can basically see, if we would take a look at the stack, it looks totally the same. Just a different naming. We have, at all times, we have 8-bit values that are stored at the exact same position on the stack. So the first value of the array is going to be at the same position in the first y0 value. The second value in the array is going to be at the same position in the y1 value. So they are going to be the same in memory, but as you can see, they are not the same, because in this case we have one variable. Just gonna say and shortcut this with var. And in this case, we have 3 variables. So if we are doing an array, we have multiple values of the same type. And if we are doing it the separate variables way, we're gonna have 3 variables of the same type. So 1 variable, 3 values, 3 variables per 1 value. So 3 variables, every one is 8-bit, every variable is having 1 value. One big array with 3 values, each value 8-bit of a size, or in our case 32-bit values. So array and different variables are exactly the same, right? They are completely the same, but it's just a different way of writing it. And that's what we want to do. We don't want to do this with single values. We want to do this with an array value. So how are we going to tell the language that we want to do an array? Can we do something like ×4 to indicate that we have 4 times an integer? No, we can't. We're going to use a special syntax in C. And basically the syntax in C is these square brackets. Adding square brackets after a name of a variable indicates that this is an array. So as you can see, if I do this, we are getting some issue. We're getting here incomplete type is not allowed. So it is kind of like recognizing that, but it is incomplete. There is one thing missing. The count is missing. How many of these types we want to have? And well, we're just going to enter the count here, and we're going to have a next issue. This is something that doesn't work in C. It works on Linux and on some compilers, but not on the Microsoft compiler. The compiler does not allow us to do a dynamic value for these y values, since this is the stack. This is still a variable. And so we need to get a bit around that. And what I'm just going to do is I'm going to put this to a maximum value of 255. So we're going to have a limit here. We're going to have a limit of 255 integers. And I'm basically just going to keep these. And to assert that these are good, we of course need to set our count. So we basically want to say if count bigger 255, we're going to set count equal to 255. So as soon as we are kind of like overshooting a count, we are setting it to 255. This is actually okay. We are just like clamping a value at a certain value. This is fine for me if you're doing this like that. So it's okay to do it like that. And now the only thing that we need to do is basically we need to use this down here. So first of all, I just want to have 1 line of code. Yeah, right. I just want to have 1 line here, and I just want to have 1 line there. All right. Simple like that. But now how can we use it? First of all, let's fix the name here to y value and y value here. And you can see that printf is actually fine with that. And this assignment is not. So what is the issue here? Well, actually, as you can see, now I am trying to access the complete array. But what do I want to do here in the iteration of the loop? Well, I actually just want to set the first element with the index 0. So basically the first element always element at index 0. You're going to see in a moment why this is the case. But what I basically want to do is I want to set the first value. How can I get to that first value? Well, we are going to use the square brackets again. So I'm basically going to add the square brackets in here as well. And as soon as I would type in a number, for example, you can see that the error goes away and the assignment works. Now let's just make this dynamic and enter the I value, and well, you would think that we are good. Now, the only thing that's missing here is we need to do the same thing here at the output as well. The printfx is not complaining because the printfx function can really accept anything. And everything you're going to put in there, it's going to deal with that. But it is not going to work. I'm going to tell you in a minute what an array really is. And then you're going to understand why this works without the accessing of the parameter or the index here. And we're going to quickly bring this in here. All right, so now let's try this out again. and enter 5 and maybe a value of 10 and execute this. That looks nice and works like a charm, right? Okay, so you can see works. And now I just want to show you something where our old application falls apart. I closed that window, that was not intended. So let's enter a value of 5 and 1000, which is going to be capped to 255. And boom, kaboot, as I would say in German. It's basically broken. And we are now getting a runtime check failure #2. Stack around the variable y value was corrupted. What does that error message mean? Well, basically what Visual Studio does, as soon as you are on debug mode, it is adding some special support checkings to your functions. So every function call that you're gonna do is guarded. So basically what the Visual Studio Runtime does is it decorates your whole stack, your whole memory setup, your whole function calls. It's decorating them all with some special debugging data. And after your function is finished, it's basically checking these decorations again. For example, it's gonna put some magic values on the stack where you are not supposed to write. So if you are trying to write beyond what your function uses, so in our case, I've used the y value of 255 elements. I could write to the 265 value. So one value above that magical like stop that I've set it. I can write over the bounds of my array because the stack is probably bigger, right? The stack is a pre-allocated block of memory, and if I write over that, like over that value, go higher than that. So for something like y value 300 equals whatever, this is probably gonna work because the stack is still allocated and it's not used. But basically what we are doing by writing over that stack value, we are setting some values that were not expected. We are basically, with that declaration, we are basically telling the compiler how many space we need, how many bytes we need. And if we write over that, it's probably gonna be fine. But it is written somewhere where we have not declared that we're going to use it. And the issue is that while this might be fine in some cases, in other cases it might not, because the memory might be used by some other functions that we are overwriting their values. Probably not in this case on the stack, but later on if we are getting to the heap and stuff like that, we're going to have issues like that. And basically it's not a good idea. If you're writing over the value that you are said you're going to use, you're going to can have issues. And basically what we are doing in debugging is, it is basically decorating the full stack that we are not supposed to use, is decorating it with magic values. And as soon as we are kind of like writing out of bounds, we are overwriting the magic values that were introduced by the runtime checks. And as soon as we are leaving the function, the runtime checks check the full stack, and then it detects that we have written somewhere where we were not supposed to write. So we basically destroyed the magic values that the runtime checks has introduced, and then it basically fails with a runtime check failure and says that the stack around the variable y value was corrupted, because it basically takes a look at the compiled data and then sees, all right, we have written, like, for example, one element more than we were supposed to write on that y value if you have written one value more. It's basically seeing, all right, this is very close to the variable named y value, so it basically prompts you an output and says, yeah, stack around the variable y value was corrupted. So this is something that we are doing on debug to basically catch errors like that, because we have made a mistake here. You might have already spotted the mistake. Well, how is our for loop working? Our for loop starts at the integer I at the value 1 and goes until count. So basically our y value travels from 1 to, at the extreme case, 255. So somewhere between 1 and 255. But I told you that our arrays are zero-based indexed. So basically the first value starts at 0, which means that the last value is from 0 to 245. So the last value that we are allowed to access is 245. But since we are using the I here and we are going smaller equal count, and count can be 255, this would be equal to setting something to 255. And if I would stop this and write the value of 255 in here, you can see that we are getting green underlines, and it's saying that the index 255 is out of range, and the valid range is 0 to 245. So the compiler and the Visual Studio IDE already knows that. And then it's also telling you that we're going to have a buffer overrun while writing to the y value, and that's exactly what happened since we went to 255. The issue is that we are going from 1 to 255. So basically we are never using the value at the index 0, but we are writing to an index that we don't own. So basically what we need to do is we need to subtract 1 again of that I value, because that I value starts at 1, but our indexing starts at 0, so the first run should write to the index 0. We can do this by writing I minus 1. Same thing down here if we are reading it. And if I would now run this with some high value like 1000, you can see it runs without giving us a runtime check failure, just runs fine, gives us all of our output and looks good, right? A few values, 255 values. We limit ourselves actually here to these values, but it works. Now that's the practical standpoint of things. Now let's get theoretical. What's happening behind the scenes? So what is an array really? So again, let's take a look at the stack. What is happening if we are creating this array of 255 integers? Again, I'm going to simplify this to the y value, to 8-bit values. Let's say we're going to simplify this to an array of the size 8. So basically, I don't want to close it. What happens is that the stack gets populated with like y value of 0 and so on. So we would have like, let's maybe populate them. Maybe I should just use 4 values because I'm lazy. So basically what's happening is something like that. We are basically populating our stack with the values of y starting at the stack address 1, for example, going to the stack address to 4. And these are now our values. But how can we address them? Well, actually we can't. We can't address them because we don't have something called y value, or we don't have a y0, we don't have a y1. We don't have these on hand. Basically, we don't know where the y values are stored. We have allocated some space for them, but we haven't stored them. So basically what we need to do is we need to basically find a way to what y value really is. What is the term y value? Because it could be like anything, right? Y value could be any value there. But what is the y value? Well, actually the y value is a pointer. That y value here is actually an int 8t pointer. And this int 8t pointer is basically pointing to 0x1, which basically is pointing to the first element of the array. And now the indexing makes sense, because now if we are basically taking the y value and basically keeping it at 0, so plus 0, would be 0x1. So this is our first element. This is basically our y value at 0. What would happen if I now want to access the y value, the next y value, the y value 1? So if I want to reach y value 1, if I want to reach it, I might need to press the trashy button again, all right? If I want to index it, I need to take my initial y value and add 1 on top of that. If I take my initial y value, add 1 on top, we are at 2. And if I want to go on to the next one, I need to add 2 on top of that, then I am at 3, which is equal to our y value at position 2. If I'm going to go even further, I need to add 3, where I then add 0x4, which is y value of 3. And basically what's happening here is that we are working with the pointer. We are getting an initial pointer that starts at the initial location where our data is stored for that array, and the index that we are specifying basically means how we are going to increment this pointer before we read it. So basically what's happening, if we want to take it as a function, so this operator, like we basically want to get an int value out of that. And the thing is, it's called an operator. In C++, you're going to have operators as hell. So basically, we want to use this bracket operator that we use. And this bracket operator is basically getting this index. I'm just going to call it index here. And basically what it is doing here, it is basically taking the initial pointer value. Maybe let's add this one in as well. So int 8t pointer base. And basically what it is doing, this function here, I'm not going to do brackets and stuff here, just some bit of a pseudocode here. Basically what we are going to do is we're going to create a insert32t pointer, a t pointer target. And the target value is going to start at base, and it's going to be incremented at 1 times index 1, because the int 8t is 8 bytes big. If it would have a 32-bit integer, it would be 4 times the index, because one 32-bit value has 4 times 8 bits, which are 4 bytes. So we need to multiply that index that we are using by 4. But just keep it simple here with 1. So basically what we are doing here is we are moving that pointer towards the index where we want to have it. If we are plugging in an index at 0, 1 times 0 is 0, so we just take our base pointer, which is the first value. But if we would input, like, for example, like the value of 3, index 3, 3 times 1 is 3, taking the base value, for example, 0x01, adding 3 on top of that is 0x04, so we would then end it up here at 0x04, y value at position 3. So we would basically go to the last value. And then the only thing that's really left to do here is to return the referenced target. So this is actually what's happening. behind that operator. If you are assigning that, it's a bit different. It's then something like, if you're assigning it, void operator, something like that, int index and int 8 t point, int 8 t pointer base and int 8 t value, then it would have something like that, which would again compute the target pointer here, which would be equal to base plus 1 times index, and then I would basically say difference target equals value. So it would be a bit different, but basically that's what's happening behind the scenes. This is done by the compiler, basically. The compiler does these functions that I have written in here with pointer arithmetics, taking a pointer and doing math with the pointer. The compiler is doing this behind the scenes. And it's also allocating this memory on the stack behind the scenes. So basically, every array is a pointer. And we can actually prove this. Int 32t pointer ptr equals to y value. And as you can see, this works because this is a pointer. The y value itself, even if we write it fancy with these array brackets, it is just a pointer. And another thing that works, you can use every pointer with these brackets. Every pointer. It doesn't matter. It doesn't matter where it's coming from, how it was declared, and in this case you can basically see that it is a uninitialized memory and that this is a null pointer, or basically a pointer to 0, to the kind of like base address, which is wrong, dereferencing null pointer PTR, and this doesn't work. This will not work and never work, but the thing is, every pointer that you're gonna face in your career of C and C++, every pointer can be used as an array. Because an array is just a pointer. An array is basically a pointer to the first value, if you're doing like that on the stack. And this is really, really important to understand. And by changing this like that, we can now constrain ourselves to our IPO principle again and do processing input first. This really doesn't matter in our case. It's like, would be more efficient to just do it like that. But that's not the point of the series. The point of the series is to understand what's happening and to make it nice and learn something. So that's the idea of arrays. And in the next video, we're going to talk about dynamic arrays and dynamic memory, because it's something that fits now. I actually wanted to continue with strings next video, but we're going to do dynamic memory first. So that's it. Let me quickly go over that again so that you get the most important points in your mind and that you know them so that we can get started. So let's summarize this. What have we done? We have created a int32 array. An array is just a collection of values, as if you would declare them as single variables, but the only difference is that it is one name for the whole range of values. So in this case, the name is called y value, the label variable y value, and it is of the type int32t, and we have 255 int32ds. Behind the scenes, we are generating a pointer to that, a pointer to the first element of the array, and we can then use it in our functions here, in our computation loop or in our print loop, to basically assign or read values on that by using the array operator here, the square brackets here, to basically index the array. And while indexing the array, it's really important that you understand that there is 0 index, so the first element has the index of 0 because it is at the same address than the pointer that we have got. This is the whole idea behind it, zero-based indexing. Since we are getting a pointer to the first element of the array, if we want to offset into the array, basically moving that pointer along through the whole array, the first index is always 0 because we don't want to move it, we want to be there as we stand, which by the way could also be done with y value. Dereferenced will basically clear the first value to 0. Again, just some off topic, but yeah. That's the whole idea of arrays. Not really complicated, but important to understand. Thank you for watching. In the next video, we're going to make this dynamic so that we don't have that hard limit here. So hope you enjoyed. Make sure to like and subscribe and have a nice day. Bye.